Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be talking about waves. So, step number one, what exactly is a wave? A wave is basically a vibration within a medium. So, let's put that down. So, a wave is a vibration, we can say or disturbance within a medium. So right now I'm speaking to you via sound waves. My vocal cords are disturbing the medium, which is going to be air in this case. Right, another classic one is going to be water. So let's say you're at the seaside and this is you in this diagram here, and someone drops a pebble into the water. So this is the pebble. Whoops, that's the wrong word. Let's say we drop a pebble into the water. So we drop the pebble into the water, what's going to happen is a wave will be created. It's the wrong colour again. Let's draw you again. So this is you afterwards. Now the pebble enters the water and a wave is created. So waves, what are they? They are vibrations or disturbances within a medium. And also they transfer energy from one place to another. Notice that the energy is now coming towards me if I'm at the seaside. So they transfer energy from one place to another. Nice, yeah, always think about waves going up and down in a nice cycle. Yeah, you're at the seaside, someone drops a pebble, you've disturbed the water. Therefore we get that ripple effect. Okay, so there are two types of waves you've got to be familiar with. Number one, it's called a transverse wave. So, a transverse wave. This one looks quite familiar. So you've probably seen this at school. This, my diagram, this is my cool, slinky spring. Yeah, so this is a slinky spring. I can't spell it. Right, and let's say I hold the slinky spring from one side and I oscillate it. That means I vibrate it. So it moves up and down. So if I move my hand now here in this direction, so I'm going to move it so my vibration is in this direction, what will we see? Well, we'll see the following be created. So the wave will go up, back down, back up again, back down, and back up again. So let's look at this, a bit more detail. This is my hand still. So what do I notice now? We get this nice S shape going along. So let's label that. So let's put that over here. So my vibrations is in this direction. But which way is the energy going? So the energy is going across. So the energy is going across. So energy transfer away from my hand. So if I move it up and down, I get this nice S shape being formed, and the energy is moving from my hand to the other side. So this is a transverse wave. Why? There's a key definition about transverse waves. It's about the relationship between the vibration and the direction of energy transfer. So what do you notice about the vibration and the energy transfer? Are they in the same direction or are they perpendicular to each other? Well, look, the vibration is up and down, the energy transfers across, so they are 90 degrees to each other. So for a transverse wave, the formal definition is this. For a transverse wave, we know that the vibrations are at 90 degrees. There's not enough space there. Let's put it somewhere else. The vibrations, the definition of a transverse wave. Okay, let's put it down a bit over here. So in a transverse wave, the vibrations are at 90 degrees to the direction of the energy transfer. And that's a formal definition of a transverse wave. Let's zoom out a bit. Let's give you a bit of space. Here we go. So if somebody asks you what is a transverse wave, we know that in a transverse wave, the vibrations are at 90 degrees to the direction of energy transfer. So that's the first one. That's a transverse wave. Right. What about the next type of wave? This one's a bit different. This is a longitudinal wave. So I've still got the slinky spring now. So it's just like before. I've got the transverse wave across, but I'm not going to move it up and down now. I'm going to move my hand in this direction. So I'm going to move my hand in this direction now. So my vibration is here. So my vibration is in this direction. So what will the slinky spring look like once I've added the vibration? It'll look like the following. So, oops, that's wrong. Let's go. Some bits will be clumped up, and some bits will be spaced out. Then some bits will be clumped up, and some bits will be spaced out. So we'll alternate now. So here's my hand once again. Wonderful. So this is the vibration. Which way is the direction of the energy transfer? Where's the energy going? It's leaving my hand, going forwards. So this is the direction of energy transfer. So how could you define a longitudinal wave? What is the relationship between the vibration and the direction of the energy transfer? We can see that they are both, are they perpendicular or are they parallel? Yes, guys, they are parallel to each other. So in this, the vibrations are parallel to the direction of energy transfer. So that's going to be for a longitudinal wave. If somebody asks you what a longitudinal wave is, you know the vibrations are parallel to the direction of the energy transfer. So they're slightly different. Make sure you know the difference between them. So in a longitudinal wave, I get this setup. Yeah, so they start to clump up together, then they spread out, they clump up together because I'm shoving it in that direction. But in a transverse wave, have a look, we get this nice S shape. So the vibration, if I'm moving it perpendicularly to the direction, it's going to move in a nice S shape. If I move it in the same direction, we get the longitudinal wave. So there's slight differences between them. So let's scroll down for a summary of this topic so far. First of all, waves are vibrations or disturbances within a medium. Notice if I have water and I drop a pebble, I'm going to disturb the medium, making some waves. Right, they transfer energy from one place to another. So waves always transmit energy from one place to another. In a transverse wave, the oscillations are at 90 degrees to the direction of energy transfer. Or some people say wave propagation, that's fine. And in a longitudinal wave, the oscillations are parallel to the direction of energy transfer. So make sure we're happy with those two definitions. It's all about the oscillations. So in a transverse wave, the oscillations are 90 degrees to the direction of energy transfer. In a longitudinal wave, the oscillations are parallel to the direction of energy transfer. And that is it for today's lesson. Oh, we'll give some examples. Okay, so let's do some examples. So if I have a transverse wave, so for transverse, classic one is going to be water waves at the seaside, water waves. Also, radio waves are also transverse. For longitudinal, this one's a bit different. Longitudinal, some examples are going to be sound waves. So sound waves are longitudinal, and the other one's going to be primary waves, which are basically earthquake waves. Yeah, so make sure we're happy with number 1, what definition of a wave, number 2, what is a transverse wave, and number 3, what is a longitudinal wave. And that's it for today's session. I shall see you next time for some more cool physics. Goodbye.